All right, let's look at the homework 8, problem 19. All right, so let's find the domain of this exponential function. All right, so since this is an exponential function, you can basically plug in any number you want. Domain would be all real numbers. So in an interval notation, it will be negative infinity to positive infinity. All right, so check the answer. All right, we got that. All right, let's see. We are talking about intercepts, right? So we want to find x-intercepts and y-intercepts. Let's find that. All right, so y-intercept. So we set the x equals 0. So f of 0 is going to be e to the 0, which is going to be 1. So y-intercept is 1. And we set this guy equal to 0, but this is an exponential function, and this is actually never 0. Alright, so there's no x-intercept, and then y-intercept is 1. Alright, so let's look at that. Alright, let's see. No x-intercept, let's see. Y-intercept is 1. Right? And then there's no x-intercept. Right? So that's that. Alright, we got that. Alright, and continue. Alright, so let's see, then we are talking about horizontal and vertical asymptotes. Alright, since this is exponential function, it doesn't really blow up at the finite x value, so there's no vertical asymptote. But horizontal asymptote, you can see that if you take the limit as x approaches a positive, actually it doesn't really matter, this is actually an even function, so positive or negative infinity, then you have e to the negative 0.5 x squared. Right? As this guy goes to positive infinity or negative infinity, x squared goes to positive infinity with the negative 0.5 in front. So this goes to negative infinity, right? So e to the negative infinity approaches 0. So y equals 0 is the horizontal asymptote. So horizontal asymptote will be y equals 0. All right. So let's see if we can find that. And let's see, y equals 0 is the horizontal asymptote, but there's no vertical asymptote. Right? Let's check the answer. Alright, we got that. Alright, next one, I'll have to hit continue. Alright, then we're going to look at the first derivative and look at the increasing, decreasing behavior of the function. Alright, so let's do that. Alright, let's see. So we take the derivative, so f prime of x is equal to, alright, so it's going to be e to the negative 0.5 x squared. Then you have to multiply by derivative of that would be negative x. Right? So we set that equal to 0. So you can see that x equals 0 because this is never 0. So we can make x equal to 0. So if you do a number line here, alright, and when x equals 0, and we look at the sign of f prime, then let's find a sample point. So anything less than 1 at 0, negative 1. Anything bigger than 0, we're going to try 1. Right? Alright, if x is negative 1, so negative, negative 1 positive, so it's going to be positive here. If x equals 1, negative 1, and it's going to be negative there. Right? Which means that the original function is initially increasing up to 0, then after that decreasing after 0. Right? So let's function is increasing on the interval, so from negative infinity to 0, and here from 0 to positive infinity. Alright, let's check the answer. Alright, we got that. Alright, I'll have to hit continue. Alright, and we were talking about, now we're going to talk about local max and local min. Let's look at the shape. All right, so the graph is here increasing, turning into decreasing. So we can see that we're going to have, we're looking at the top of the valley. So we're going to have a local maximum there. So local maximum at the x equals 0. Right? So it has a local maximum at the 0. Right? But there's no minimum. Right? So here. Right? Let's check the answer. Right? We got that. All right, next one, and click to continue. All right, so we have, let's say, function concavity. All right, so let's look at the concavity of this function here. All right, so we have to look at the second derivative. So here's the first derivative. So second derivative would be f double prime of x is equal to, alright, derivative of the first guy is the -1 and times the second, e to the -0.5 x squared, and plus derivative of first guy is -x, so I'm going to put the -x there, and then multiply by derivative of that guy is -x e to the -0.5 x squared. Alright? So what you get is going to be, let's see what's in common. So you have e to the -0.5 x squared. So here's x squared. So I'm going to put the x squared here. And here's -1, so -1. Right? And we set that equal to 0. Right? So you see that here, plus or minus 1, set x squared minus 1 equal to 0. So plus or minus 1 would be where the second derivative becomes 0. All right, so let's do the number line just like before. And we're going to put a -1 here and a +1 there. And we're going to look at the sign of second derivative. All right, so anything less than -1, so I'm going to try -2. Between -1 and 1, I'm going to try 0. And bigger than 1, I'm going to try 2. All right, so here. If you plug in -2 squared minus 1, so that's going to be positive. Right? Exponential part is always positive. If you plug in 0, that's going to be negative. If you plug in 2, that's going to be positive. All right? So the original function here is going to have concave upward shape, then between -1 and 1, concave downward shape, and then after that, concave upward. Right, so let's type it in. Right, a function is concave downward on. Right, so concave downward between -1 and +1, and concave upward on -infinity to -1, and +1 to +infinity. Right, and let's say use the integer decimal. Okay, then use comma to, right, so here. Right, we got that. All right, next one is inflection points. All right, so we have, all right, so it looks like a concavity change occurs at the -1 and a +1. So you can see that there's going to be inflection point there because there's a concavity change, and here there's a concavity change. So it's at the -1 and a +1. So I'm going to just put -1 comma +1. Right, check the answer. All right, we got that. All right, then we'll have to choose the correct picture. So let's go back and look at the shape. So it has to be increasing, turning into decreasing. So let's check that. All right, increasing, turning into decreasing. So first one looks okay. B doesn't follow that. Increasing, turning into decreasing. But C is not going to be it because it looks like there's going to be some sort of vertical asymptote, which this function does not have. All right, then you have increasing, decreasing. D does not follow that. So actually A is the only reasonable one. So let's check the answer. All right, we got that. And that's it. I hope that this was clear.